I'm going to go over the practice problems first for density. The first problem, what is the volume in cubic meters of a rectangular solid that is 0.25 meters long, 6.1 meters wide, and 4.9 meters high? Make sure as I'm going through them, you're correcting your papers so that you know what to study from. You will have a density and dimensional analysis quiz tomorrow in class. It is a paper quiz. So we want to find the volume. We know our length. We know how wide. And we know how high. So volume equals length times width times height. I plug in my measurements into my equation. And then I have 2 sig figs for the length, 2 sig figs for the width, 2 sig figs for the height. When you multiply and divide, it's the least number of sig figs. So your answer should have 2 sig figs. You get 7.5 meters cubed. And I would expect to see everything on the right side of the screen, the equation, the numbers in the equation, and your final answer with correct units and sig figs when you're doing a problem like this. Problem number 17. Find the density of a material given, so we're trying to find density. We have a mass of 5.03 grams. We have a volume of 3.24 milliliters. And so we know density equals mass divided by volume. Density equals mass, which is the 5.03 grams, divided by the volume, 3.24 milliliters. My mass has 3 sig figs. My volume has 3 sig figs. So your answer, your density value should have 3 sig figs, 1.55, and it's grams per milliliter. Again, I would expect to see the equation you wrote, the numbers in the equation, and your answer with correct units and sig figs when doing a density problem. Number 18. What is the mass of a sample that has a volume of 55.1 centimeters cubed and a density equal to 6.72 grams per centimeter cubed? In this case, we have density and volume. We're trying to find the mass. We can use the density as a conversion factor to convert from volume to mass. So I start with my volume. I'm going to set up my railroad tracks. The units here, I move down. The units I want, which is the mass, are grams, go up here. This is density. And so the density of this sample is 6.72 grams per 1 centimeter cubed. For dimensional analysis problems, you multiply the top of your railroad tracks, you multiply the bottom of your railroad tracks, and you divide. These units cancel. I have 3 sig figs for my volume. I have 3 sig figs for my mass. You should have 3 sig figs for your mass, because you had 3 for your volume and you had 3 for your density. If you left your answer as 370 grams, that would only have 2 sig figs. You would have to write 370 with a decimal point to give 3 sig figs. I would expect to see the work that I have here for these problems, and you do have to use dimensional analysis to solve these problems. For number 19, A sample of a substance has a density equal to 0.824 grams per milliliter. It has a mass of 0.451 grams. We want to find the volume of the sample. Again, we have our density, so we're going to use that as our conversion factor. So I'm going to start with my mass, set up my railroad tracks. These units here I bring down. The units I want, which in this case will be volume milliliters, go up here. This is density. Density is how many grams per 1 unit volume. So it's 0.824 grams per 1 milliliter. You multiply the top of your railroad tracks, you multiply the bottom of your railroad tracks, and then you divide. And units cancel diagonally. You'll be left with milliliters. I have 3 sig figs for my mass. I have 3 sig figs for my density. So my volume should have 3 sig figs. If you are having trouble with the density problems, you can go to room 329 after school today for some tutoring, or I will also be here tomorrow morning before school at 6:45. You could just pause the video for a moment and hand out the target density labs. I'm going to go over your scores on the target density labs. So hand those back. And those of you who have not done the target density lab, you can go out in the hall for a moment while I discuss the grades on these. So the first 3 parts, part A, part B, and part C, were performance-based. So you got a score out of 5. 5 was the maximum. If you didn't get a 5, you lost however many points. So those are self-explanatory. When you get to here, and this is what I wrote in class, you had to show your work. So if you lost points, it's because you did not show your work. And you will have a table like this to complete on your quiz tomorrow. You will have data to graph, and then you will have to complete a table. You have to show me your subtraction of your higher and lower volume. You have to show me your subtraction of your higher and lower mass. You have to show me the calculation of density. And I saw a lot of papers where some of you did not have the correct formula for density. Density equals mass divided by volume. Mass is in grams, the volume is in milliliters. So if you lost points here, you could have lost points for not showing work. You could have lost points for not having units. If I looked at your data points and they did not match your graph, I took off points for that. I wrote notes on there. If you have questions, you can see me tomorrow. On the graph, and this is what you're going to need for the quiz tomorrow, you need a title for the whole graph. So if you have an X at the top, I took off a point for not having a title. You need, and I'm going to make this a little smaller, you need a title for your y-axis. So this should have been your mass. And this should have been your volume. Now, some of you did not put a title, so you lost points for that. Some of you, your increments did not make sense. You should have started at 0 for both of those. And you need to use the entire sheet of graph paper. So your increments for mass should have gone all the way from the bottom to the top. Your increments for volume should go all the way from the left to the right. And when you do plot your points, you're going to do a best fit line that goes through the y-intercept. Some of you drew it down through the origin. You need to draw it through the y-intercept. And so your graphs on your quiz will be graded for titles, that you appropriately graph the data, and that you draw a line through the y-intercept. Also, when you pick your high point and your low point for the quiz, please pick them so they're not right close to each other. And they should not be the data points given to you. It was out of 25 points total, taken as a 100-point lab assignment, so your percentage is on there. If you have questions, please see me. You can pause the video for a moment and get out your devices, log into Schoology, go to our course materials page. So I'll go ahead and pause the video while students do that. So once you get into Schoology, I want you to go to the Chapter 2 folder, go to the Chapter 2 labs, and I want you to open up the Blue Ice lab. And so you're going to open up, and I will too, this document here. You need to make sure before you click on that you are logged in to your Google Drive account, the one you plan to use for my entire class. And so when you click on this, you're going to open up a Google Drive template. What you're going to do today is you're going to write your Blue Ice lab report, the pre-lab part, the action. You're going to type it in step by step, and I'm going to open up my OneNote to show you, to go over a few things, a few reminders. But you're going to type this step by step, the Blue Ice lab. You're doing it yourself. You also need to make 2 data tables. You're not filling them in yet. You're just going to arrange your data tables so you have them done for the lab. And so this is the whole template. When you finish this, you will take everything out that is in blue. That's part of the rubric, which we'll look at in just a minute. But what you have to do today with your lab partner, and there will be a list put up on the screen, you need to type in your step-by-step procedure of what you're going to do for the lab next week. Every person has to do this. You have to print it off, and it is due this week on Thursday at the beginning of class. If you look at the lab assignment itself, there's a rubric. I always recommend you look through the rubric for what I'm expecting. It talks about what you need for your procedure. It talks about what you need for your qualitative data table, your quantitative data table. You will have to take pictures next Monday when you do the lab, what's required for your graph, and then the conclusion that you'll be completing. And we'll do some more discussion before the lab is all actually due. But you are going to write your procedure today. And so if we go to the Blue Ice question, I just want to go over a few reminders, things that we've already talked about all unit, as far as the Blue Ice phenomena. So we know one of the questions on the Wonder Wall is that the ice cube is water. It's not a trick ice cube. It's water with blue food coloring. Nothing's different about the ice cube. We do know after this unit that solution A and solution B are different. They are not the same. Solution A is a more dense solution than solution B. We know that solution B is water. So you're going to have to pick with your group what solute you're going to use for solution A. And so I will have a Google form for you to fill out. It'll be in the lab folder for you to tell me what solute you are using so that I know that so I know what to have out for lab. We also know that we have qualitative data to record. that we are recording the temperature of the top and the bottom of both beakers every 30 seconds. And so on the desk is this setup, but I'm going to go through what it all is so that you know the words so that you can write your pre-lab. So this is a thermometer holder. And this part goes onto the ring stand. And your thermometer goes here. This is the ring stand. This part is your ring stand. So you will need one of those out. They're found in the door of your lab drawer. And you can see the thermometer holder is attached to that. And again, I have an example on my desk. And then with the thermometers, this is how you will set it up. You have a thermometer. This is the thermometer for the top. And then this is the thermometer for the bottom. And you will not want to move these in and out. Once you set it up, you kind of want to just leave it so that you're not disturbing the solution in the beaker. And you will do this for both beakers A and B. So as far as lab groups, you have your group of 3 or 4 that you sit with. That was the same group you went back for the blue ice lab, that you went back for the measurement stations. That is the large group for this lab. I will divide you into groups of 2 from that, just like I did for the target density lab. So you can, for now, work in your group of 3 or 4 today to write your lab procedure. Everybody has to write one, but know that I will divide you into smaller groups of 2. Usually the person sitting right across from you will be your lab partner. If someone's absent, then it'll be your group of 4 will go, or your group of 2 will become a group of 3, like we did for the target density lab. For the rest of the class period, you should be writing your pre-lab step by step into this, and this is in your Google Drive document, writing your action step by step, and you will print that off and turn that into me on Thursday. If you get that done, you have a quiz to study for. Tomorrow's quiz is over dimensional analysis conversions and metric conversions and density problems. Again, you can go to room 329 after school today for tutoring, or you can see me tomorrow morning at 6:45. Please work on your pre-lab or study for your quiz.